authentication via ACS, the access control system that has been built into the Microsoft cloud. Again, this apparatus is also available through the cloud-ready packages for devices that Microsoft provides. So again, no need on your part to build this code. Just put it in place from a Microsoft perspective and inside the account you have with Windows Azure. What does this system do? How does it work? The idea here is that users, people like you and I, often have accounts through things like, well, Google or Yahoo or Facebook, whatever the case might be. You have that account set up, and what we can do is point Microsoft Windows Azure Cloud and a hosted service that comes with the cloud-ready packages to those various, if you will, federated or identifier capabilities, and then allow our applications to use those identifying capabilities, if you will, those namespaces provided by groups like Google and Facebook and such to authenticate our users into our application. The namespace providers, the Googles, the Facebooks, the Windows Live ID, etc., those are the folks who are now essentially providing the identity and proof of who they are, the authentication data, if you will. Our Windows Cloud mechanism now just allows us to take advantage of all that data. This is a bit more complex to set up, as you might imagine. You simply put the cloud-ready packages into the Azure cloud, but then you also have to set up what is this ACS namespace, essentially point Windows Azure to all of those namespaces and account mechanisms that are out there to provide for identities and grant those folks who are part of those identities access to your application. Setting up that ACS or the Access Control Service namespace isn't exactly for first-day developers. It takes a little bit of work. On the positive side, applications now know absolutely nothing again about your Azure account, again, except for your service URL, and now no membership management. In other words, you don't have to worry about a database that keeps track of all the users. That's all, again, being provided by these identity providers. And they're granting and denying access or granting and allowing access through their own service. You're just taking advantage of those providers out there. So this is a great way to leverage what are already kind of proven identity providers out there to allow for access to your data storage. Okay, so those are kind of the basics of the Windows Azure Toolkit for Android. We're going to come back and take a look at some API, look at a couple of demos there about how it works and get into some more of the details. But before I do that, I want to kind of do a level set here and make sure people have at least some basic understanding of Android development. Nothing real complex here. In fact, if you can walk away today and be able to build an Android application from what I'm about to provide you, I'd be a little bit surprised. It's just enough to kind of give you a basic understanding of how Android works, what its architecture is like, how to get a first hello world type of application up and running. From there, I would leave it obviously to your ability to go out and do a little bit more work on this avenue. However, let me, before I get too deep into Android development, let me find out if there is already a pretty good sense of what Android development is about. So if you can, fill out my next poll here and let me know what your skill level is with regard to Android. Okay, so it looks like some people are just kind of getting started in Android. Okay, great. All right, so as I kind of expected, I figured most people probably would have little or no knowledge of Android or just kind of getting up and spinning into Android development. So probably a good way for us to spend a little bit of time here is just talk a little bit about Android development. Again, nothing big, but just give people a little bit of appreciation about how Android applications work so you know how they can tie into Windows Azure. Great, thanks folks. Let me return now to our content here. Okay, so just the basics here. First of all, Android applications. How are they built, what are they manufactured out of, things of that nature. Bottom line basics here is we're talking about Java applications. Now, while we say that Android applications are Java applications, what we have to also understand is a different form or different flavor of Java, if you will. Yep, we still write normal Java programming code, but this code gets compiled down into something that actually runs on a different form of virtual machine, something called the Dalvik virtual machine, or Dalvik executable is what we run inside the Dalvik virtual machine. So a little bit of a different process here. Thankfully, a lot of the tools that we work with in the Java arena have been outfitted to work with Android applications. We'll talk more about that in a bit. But there are some definite differences between what we would call quote-unquote normal Java and Android Java. For example, a lot of the libraries out there would actually be missing. Libraries, for example, to connect to databases, JDBC are missing. Libraries to do what is Java user interfaces, Swing libraries are missing. Right? So there's some libraries that are missing, and then there are some additional libraries provided that are unique to Android. Libraries, obviously, to get and bring up the phone and make a call. Libraries to access things like the GPS capability on the device, as well as the libraries to do what are Android-specific types of capabilities. For example, talk to the Android SQLite database, which is a bit unique from a Java perspective. So there are some things that are added, some things that have been removed, and we're running on a different virtual machine. That virtual machine, again, the Dalvik virtual machine, is still a Java virtual machine, but it's not quite the same. Again, this is a virtual machine that has supposed to have been developed from the ground up. Now, this is, and I'll bring up kind of a point here, this is from the perspective of Oracle/Sun and Google, kind of the source of a bit of a problem. There's actually a lawsuit out in place right now from Oracle claiming that the Android community, in fact, Google, did not develop this platform from the ground up, and so we'll have to kind of stay tuned to see how that works its way out. But it does run a little bit differently, works on processes a little bit differently. We'll talk a little bit about some of those things as we go forward here. Won't get into a lot of the details. But from a developer's perspective, you're still writing Java code and actually dealing with what are normal Java libraries for the most part. And then, of course, underneath all this, what Android runs on is a Linux kernel. And that's a bit unique as well. For those who have some experience with Linux, yep, you can actually get on to an Android device and actually, peer in and see part of the Linux operating system. If you actually pull up some tools, you can actually see some of the file space in what is good old-fashioned Linux types of ways. So it is available to look at. You can actually share things all the way down to the kernel in some cases, depending on the device provider. And yes, there actually are things like C and C++ libraries at its heart. In fact, most of those libraries are exposed to Java developers through the application framework, but there is actually something called Android native development, which allows you to develop applications directly in C or C++ code as well. So that's kind of the stack of, if you will, the technologies that work on the Android device. As far as development is concerned, what you need if you are an Android developer, again, it is a Java platform, so in fact, we still need the Java JDK. On top of that, you have something called the Android SDK, essentially the libraries and the makeup that develops applications that actually give you the Dalvik executables. Compile is pretty much the same process as far as a Java concern is, but actually producing what goes on the Android device is a little bit different. There's some processes as part of that Android SDK that actually creates something known as a DEX file that actually gets deployed into and running on your application. You'll also need something called the Eclipse IDE. For those who are not Java developers, this is essentially the equivalent in the Java community of Visual Studio. Not that there aren't other IDEs in the Java community, but this is the one that's been probably best outfitted to deal with Android development today. All open source technology as well, so free of charge. So the Eclipse IDE is our basic Java development platform. In that platform, you're also going to need to tie it into what is known as the Android Eclipse plugin. In other words, give us the ability through our IDE to actually work with the Android SDK and bring up things like emulators, and we'll take a look at that and talk about that here in a bit. In fact, when you're doing Android development, you don't need a device. You don't actually have to have an Android device. It's always helpful to kind of do your final testing on an Android device to make sure things work as you expect, but you don't actually need a device. There are plenty of emulators out there to simulate running in all sorts of different platforms, from tablets down to the smallest of smartphones. And that's about it. Really, no additional tools are necessary. In fact, when you're doing Windows Azure development for the Android device, you don't need any additional tools. Yep, you will need, again, that Windows Azure toolkit, but that's just essentially a set of libraries that you use on top of this development platform. So more on that in a bit, but that's the baseline of the types of tools you'll need to get up and running in Android.